Okay, to solve this, to fill in the blanks, you pretty much have to turn the sides into triangles. So that would become like that. That would be 1, 1/2, and 3, root 3 over 2. And so 1/2 is over there, and root 3 over 2 is the x. And so you're going across, and think of it as a point going across and then up. And same thing with that one, and that you go over root 2 over 2, and you go up root 2 over 2. And same for the next one, you will be going, you'll be making it into a triangle, you'll be going over 1/2, and then going up root 3 over 2. Like so. And now, to go up, it's pretty much you go up, your x is 0, and your y is 1, so you go up 1. And same for that one, the x is 1, the y is 0, and there you go. Okay, to solve the rest of these coordinates, you just have to think of them as coordinates. But this time, you just mirror the other side. So that's going to be, and how I like to memorize them is to think of all of them to be over 2. And so whatever's on that side is going to be this side, but mirrored. So it's going to be, but except the x's are going to be negative and the y value is going to be positive. As you can see, it mirrors. And now we're going to solve the bottom. That's the same thing as I said, they're all going to be over 2. And now we're going to solve this side. So this side is going to mirror what's on top of it. But except the x values are going to be negative and the y value is going to be positive. And the other side, it's going to copy that side, the third side that I was just talking about, but except both x and y are going to be negative. This side, the y side is going to be positive. And now we're going to solve the radians. Think of it as 3, 4, 6. 3, 4, 6. That's going to be the denominator. Same thing as the other side. Again, it's going to be mirrored 3, 4, 6. The bottom, 3, 4, 6. And I kind of wrote that in the degrees. And so, yeah, mirror 3, 4, 6. And now this side, all the numerators are going to be pi, and on this side, all the numerators are going to be pi, but except it's going to be 1 less than the denominator, so 2, 3, and 5. And this side, it's going to be 1 more than the denominator, and you add pi at the same time. So 7, 5, and 4. This one, you multiply by 2, and then you subtract 1. So that's going to be 5, 7 pi, and 11 pi. And now to solve this, that's going to be 0, that's going to be pi, that's going to be pi over 2, this is going to be 3 pi over 2. And now we're going to solve, what am I solving? Oh, I'm taking out my calculator. We're going to do the degrees. Oh, wait, that's also 2 pi, sorry. That's going to be 30 degrees, that's 0. That's 30 degrees. Okay, you add 15, and then that's going to be 45 degrees, as like my calculator said. And then the next one, you add 15 again, that's going to be 60 degrees. And at the end, you add 30 degrees, and that's going to add up to 90 degrees. And so remember, it's going to be 30, 15, 15, 30. And that you just keep doing that, repeat it, to go through the whole entire thing. And just a reminder, you're going to add 30 right. Oh, wait. I ran out of lead. Okay. So, I got a new pencil. Play golf. Get out of here. Okay. Anyways, that's gonna be plus 30, plus 15, plus 15, and plus 30. And then repeat 30, 15, 15, 30. And now we're gonna repeat 30, 15, 15, 30, 30, 15, 15, 30, on and on. So, I'm blanking out. Okay, there we go. Keep writing, Bruce. There we go. Add. Boom, 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 boom. And that's gonna be 3,130. Right? No, 3,130. More like 330 degrees. Okay. the coordinates on the sides. And now that's going to be found there, 0, -1, and I am done with this circle.
Okay, the first part of this problem is to know that the sign of x is the y values on the unit circle, so all of these y values here. So it's going to go 0, 0, pi over 2 goes to 1, pi is 0, 3 pi over 2 is -1, and 2 pi is 0. And then because it says 3 sine x here, you're going to multiply all of these values by 3. So it gets stretched like this. The 1 becomes 3, the 0 stays 0, and the -1 becomes a -3. The amplitude is how high it is at its highest point, so it's 3. And the period is how long it takes to go up and down and back. So that's 2 pi, because that's how long the line is. For this one, the cosine are the y values here, or the x values here. It's the x values on this here. So that's 1, 0, -1, 0, and 1. And because the 2 is after the cosine instead of before like it was up here, you're going to divide all these values by 2. So it brings it in this way. It's a horizontal shrink. So this becomes 0, and then that, everything just shrinks. The amplitude is 1 because you don't change anything vertically, and the cycle for g of x is pi because that's how long it takes for this to go from up to down to back where it was.
Okay, so I'm going to show you how the calculations for angle and side lengths of right triangles are calculated using the 6 trigonometric functions. First off, there are 6 functions that are the core of trigonometry. The 3 primary ones that you'll need to understand completely are sine, cosine, and tangent. The other 3 are not used as often, but can be derived from the 3 primary functions, which are secant, cosecant, and cotangent. All the following 6 functions have 3-letter abbreviations. So let's consider this triangle right here. For each angle, P and Q, there are 6 functions. Each function is the ratio of 2 sides of the triangle. The only difference between the 6 functions is which pair of sides we use. So let's use an example here. A, right here, is the length of the side adjacent to the angle x, as shown below. O is the length of the side opposite of x. And then H is the hypotenuse of x. So now I'm going to teach you how to find the 3 primary functions using the angle measure, x, which represents the measure of the angle in either degrees or radians. So given that sine equals opposite over hypotenuse, sine of x is equal to opposite over hypotenuse. Now for cosine of x. Cosine is equal to adjacent over hypotenuse. Therefore, giving you cosine of x is equal to adjacent over hypotenuse. Okay, now for tangent. Tangent is said to be opposite over adjacent. So tangent of x is equal to opposite over adjacent. Okay, now I'm going to show you the other 3, cosecant, secant, and cotangent. So we're going to start off with cosecant. Cosecant of x is equal to hypotenuse over opposite. So basically, cosecant is the opposite of sine. So cosecant of x is equal to hypotenuse over opposite. Okay, now we are on to secant. Secant is said to be hypotenuse over adjacent. And secant is the opposite of cosine. So secant of x is equal to hypotenuse over adjacent. And last but not least, cotangent. Cotangent is adjacent over opposite, and cotangent is the opposite of tangent, which is opposite over adjacent. So the cotangent of x is adjacent over opposite.